All right. The next section we've got to cover before we jump into probability. Probability is it. After this section, we literally have probability, and we are finished with all material in Discrete.
Say it again.
And I'm sorry.
So, my goal is to have everything done before senior assembly. That means when we come back from Memorial Day, it's review, and I'm going to drive you nuts.
Oh my
Because
God.
we are going to go back over every chapter. Too late? I already drive you nuts.
Yes.
Score! I do my job well. Okay. So, now, this says matrix review. Because back in the day, when we used to teach math, shut up, Naiwan. Okay. Back in the day when we used to teach math, we used to teach systems of equations using matrices. Okay, we use matrices a lot. I'm not quite sure why we reverted backwards out of them because I think they're easier than doing systems like we do now. But sorry, I didn't mean to like
almost knock me out
in the process. So a matrix is just a rectangular arrangement of numbers that give you data. Okay, so you've got rows. Rows go from left to right. Okay, rows go from left to right. Your columns go up and down. Okay. So, an example of a matrix. We've got 4 pizza restaurants. Gina's, Vinny's, Tony's, and Sal's. So your restaurants are your columns. Okay? These are your columns. So the restaurants are your columns. Each restaurant sells pizza, drinks, and salads. So your items are your rows. Okay. So all a matrix is what did I take away when I created a matrix? The restaurants. I took away the titles of the restaurants and I took away the titles of the items. This is a matrix. Okay. So what this is telling me is if I go to Gina's and I order pizza, that's $12.16. If I go to Tony's and order a drink, what am I paying?
109. Oh,
89 cents. Tony's is in the third column. And your drinks are in the second row. So it's 89 cents. Okay.
If you go to Domino's, you can get a large for $7.99.
You know she had to promote her work. Do you get paid for that? Should we send this YouTube video to
The more
her?
you order pizza, the more I make, the more I also get a raise.
Okay. The numbers in your matrix are what we call elements. Okay. So you need to be able to look at a matrix and pull out an element or possibly tell me where that element is. So for an example, if I'm looking for A sub 1, 4, okay, that means I'm looking at row 1, column 4. So go to your first row and go to your fourth column and find what number goes there.
What?
First,
She literally, is
the
that
first
that looks
row
like
in the fourth
14.
column. It is, but I guess she reads it differently.
There's 14. Well, we just established.
I guess she's just reading it differently, like separately.
Kimberly, you would do that booty short though. I was just kidding.
Oh,
Yeah, step in there,
right.
and watch her bleed. I'm gonna step in her ear and watch her bleed. They're fancy. No, those booty shorts. No, yeah.
Tell her, Kimberly, they're sports shorts.
I wish it was B-Day.
What's up? What's that?
If y'all miss your first, let me know. You missed out.
See, I got my stuff up.
Oh, right, right. So she missed out.
You know, I'm up there.
Oh, that's I forgot. You need to come in
I was
for it.
getting mud.
Some of your service yesterday is gone.
It was already fucked up.
And then she said she's doing this.
Like, that shit was dry, the whole thing was gone. The whole part was
Yeah.
And we were so slow yesterday, especially Frank. We had nobody coming. He let me home.
I was driving.
Okay, so you know how I post in my my manager's hours?
But I wasn't that happy because I be more out.
He does work like 100 hours. And I told her, I was like, you're crazy. I don't even think that's why. You're like, dang, do you live here or something?
Looking the hell out of my grandma's shit. I was looking at the problem. I thought you
Well,
might
I told mom, I was like, mom,
I started talking about knowing that this was coming.
live where? He was like, she get a job.
fuck all the way down the street though. I'm damn good shoot my shit.
She was good at it.
This one, grandma, she shoot my shit.
She was saying, she was like, you can't even do your own laundry.
She gonna
You
get-
don't know which basket's the trash or the one for your clothes, like you'll just leave it there.
Oh, I get it. Figure.
No, I mean,
I'm fucking this one. I was before I got my shit shot. My grandma's shit shot.
she having the share of seven.
Oh, yeah, like I grew my son was upstate right after graduating.
Oh, how you look? Hey, look.
If I'm not paying for my homework,
Yeah, right.
I will run to the house and like I did my.
Yeah.
I'll give my mom like.
Got it. Thanks, Ashley.
All right, so if we look in row 1, column 4, what do we find?
1065.
1065.
Ashley showed us.
Okay. Did you?
Yeah.
Yay, Miss Smith.
She should be the teacher on something.
Didn't she say today? She said I'm the Black Miss Smith. I said okay.
She said that.
Y'all didn't hear me say that?
I did not hear that part.
Okay. So if I ask you to find what value is in A sub 2 1,
$1.15.
115. This means second row, first column. So I'm going down to the second row over 1. So that's 115. What about if I switch it and I do A sub 1 2?
1010.
1010. A sub 3 4.
385.
385. Okay. On the other side, they want you to tell me, where do I find this number?
A sub 11.
Okay,
Oh, it's
A
a
sub
1.
11. It's in the first row, first column. 105,
A sub 24.
24, and 369.
A sub 32.
That's like the easiest thing we did.
I told you, we got this.
Who should did this in the beginning?
Mm-mm.
She's in the first.
Okay, so not too bad, right?
Nope.
So far, so good. Okay.
But it's gonna get hard.
No. Oops, wrong way. Okay, so notice this time we're looking at B. Why am I looking at B? Because they decided that this is matrix B. They called it B. They can call it any letter they want. So this could be matrix F. You want to use the letter that goes with the matrix. So what is the value of B sub 3 2?
3.
37.
Whoa. Whoa, that. What about B sub 13?
12.
Wait, hold up. Can you do that again?
You're fine. B sub 13? Or do you want me to do them both?
Do them both.
Okay. So B sub 32. That means I'm going 1, 2, 3 rows down, 2 columns in. 1, 2.
Oh.
Okay. It's always row by column. Always row, column, row, column. So when I do 13, I'm in the first row. So I'm here. I'm in the third column, so I'm here, which puts me at 12. Okay.
So 4.
So far, so good.
This is
What's the hard part?
Identify the location of 4.
At D sub 22.
22. Okay, it's in the second row, second column. What about 15?
43.
43.
Wait. Why, what? You lost me. It's the 4th row going down.
Fourth row.
Talk to me, Smith. Alright.
You're fine. Fourth
I
row.
know.
1, 2, 3, 4. So we're in that bottom row. Third column. So we're the third number in from the left.
This is so easy.
Do you get it now?
Oh my goodness. Be nice.
No, it's never that. Booty shorts. Stay over there.
Okay.
There's not, there's sport.
Number 7 should be super easy. If I'm looking for N sub 56, what row am I looking at? 5.
Five.
What column?
6.
Oh,
What about N sub 21?
7, 4.
What?
She moved over here.
Oh. my bad.
7, 4, 2, 1.
4, 9.
Row 4, column 9.
Let's have a test right now. Come back right up.
I was gonna say, where'd she get 7 and 4
Yes,
from?
yes.
I was like, I didn't even see 7 and 4. Oh, here goes the hard part, talking about dimensions.
Don't say here comes the hard part,
No.
because it's not.
Yes, it is.
Stop.
Hey, so,
Okay.
where are we stopping at so I can get a good point?
Okay. Each matrix has what we call dimensions. Okay, so it's kind of like your area of the matrix. Okay, length times width, where length is how many rows do I have, and width is how many columns do I have. So to list your dimensions, it's row by column. Okay, I recopied these over from the first page so we didn't have to flip back and forth. So if you look at matrix A, how many rows do I have?
3,
How many columns do I have?
4.
So this matrix is a 3 by 4. What if we switch it up and look at matrix B? Row by column.
4 by 3.
4 by 3. Okay.
Was this
So-
supposed to be on our page too? Because it's not.
Huh?
I said, was those 2 graphs supposed to be on our page too?
No,
Oh,
I just copied them over so we didn't have to flip back and forth.
okay.
So how many elements are in matrix A?
12.
12. How many elements are in matrix B?
12.
How do you think you got that without sitting there and counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10?
3
times
times
three?
4.
I did 2, 4, 6, 8.
3 times 4. 4 times 3.
12.
Ew.
Your dimensions tell you how many are in the matrix. So, in other words, if I have a matrix that's 2 by 8, how many elements are inside?
16.
16.
Oh, easy.
What if I have a matrix that's 7 by 1?
7.
7,
5 by 6.
30.
30, 9. Hey, hold on.
Wait.
9. She's jumping. She's jumping.
18.
18
8.
And 8.
and 8.
You guys are just hobos.
Hobos.
What are you?
Booty shorts.
Oh my god, there's 40.
Booty shorts.
Butt was out. Coming in here. Like, ain't no pants
They
on.
were two. I have a big.
I'm like, Kimberly, put
Oh,
your shirt
Oh,
up.
that's
What did I do
mine.
with mine?
I don't know.
That's over here.
I was just gonna rip my paper.
My bad.
Yeah.
All right. So we have 2 very special matrices. Okay, they're called a column matrix and a row matrix. Okay, a column matrix is 1 column, but as many rows as I want. And a row matrix is 1 row and as many columns as I want. So if we go back to that original matrix where we talked about the 4 restaurants, okay, and the pizza, the drink, and the salads for the restaurants. It was pizza, drink, and salad. Right?
Yeah.
Okay. Each restaurant individually is what we call a column matrix. Okay. So this is Sal's menu items. This is Sal's column matrix. They want us to write a column matrix for Vinnie's. So all I'm looking at to do a column matrix is Vinnie's prices. So if you would flip back, Vinnie's has $10.10, good. $10.10 is what they charge for pizza. What do they charge for drinks?
109,
$109. And what do they charge for salad?
$360.
$369. So this is a column matrix that represents Vinnie's restaurant. Again, one column, but it can have as many numbers in that column that we want. A row matrix goes the opposite way. So my rows are my pizza prices, my drink prices, and my salad prices. So they gave you all of the pizza prices for all the restaurants. Now they want us to create a row matrix for the salad prices. So the first restaurant was
405.
Gina's. And Gina charges
405.
$405. Vinny charges
$360.
$369. Tony charges $389. And Sal charges $385. Okay. So again, those numbers did not come out of thin air. Those are that first matrix that we looked at with all the 4 restaurants and the 3 items that they sell at their restaurants. So you may see problems where you have to write a matrix. Wha-bam. Here we go.
Ah, jump.
Wha-bam. Okay. The most important thing that you pay attention to when you're filling in a matrix is what do they want the columns to represent? What do they want the rows to represent? Because if you don't put them in the right order, it's wrong. You've got to pay attention. So this says a garment company receives orders from 3 clothing shops. Shop 1 orders 25 jackets. Shop 2, 75 shirts. Shop 75 shirts, 75 pairs of pants. Shop 2 then has 30 jackets, 55 pants, 45 shirts. Shop 3 has 40 shirts, 20 jackets, 35 pairs of pants. Display this information in a matrix with columns as jackets, shirts, and pants. So my columns, my first column should be jackets. My second column should be shirts. And my last column should be pants. Okay, so if jackets, shirts, and pants are going to be my columns, what's my rows going to be? Okay, Tanisha said shop 1, shop 2, and shop 3. Okay, now we just need to fill in the numbers. Shop 1, how many jackets does shop 1 have?
25.
25. So shop 1 under jackets should be 25. How many shirts?
75.
And how many pairs of pants?
No, 75.
75 again. Okay? 25, 75, 75.
Oh, I got this.
Shop 2. How many jackets? 30. How many shirts? 45.
Oh, they mixing it up.
Aha.
They slick.
Pairs of pants was 55. Notice when they listed it, they went jackets, pants, and shirts. The first one went in order. So most of you go bam, 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 and then think that the rest of them are just going to go right in order. Please pay attention. Okay, because if you would have switched those numbers up, it would have been wrong. Shop 3, jackets,
20.
shirts,
40.
pairs of pants.
30.
Beautiful.
Oh, it is 35. Yeah, I didn't mind that.
So here's your matrix. Right there. What size is this matrix?
3 by 3. I mean,
3 by 3, which means how many elements are there?
9.
9. Beautiful. Okay. You all right with creating a matrix from a word problem? Because I know I did not leave a lot of room for that last one. I don't think I left any room.
You did.
Because I suck. Moving on. Okay. All right. Last thing we need to talk about today and we'll be finished. Lesson 2. Yeah, we got to go to the meeting here in
Oh, yeah.
30
You even
minutes.
know what it's about.
I have
We
no
gotta-
idea.
we
It's
gotta
something
fill
about
out-
senior survey,
We
something.
gotta fill out a survey of what
Yeah.
we're doing in there, going to talk about like the
I
senior.
thought you said Arizona.
What? Tell about me, Frank. I'm not fucking staying here and sleep.
Man, no, let's say on Miss
If
Kirby.
we had time to do it,
She gonna
that's
make that
fine.
little DS announcement talking about some people
Hey,
that are
hey,
late
hey.
right after I walked in. And nobody
Enough.
walked after me.
Enough. Enough. On your own time, please. On your own time, please.
I can talk about how qualified they are.
Yeah, Cozy, shut up.
Okay. So, what does it mean to be symmetric? Same on both sides, okay? So if I'm symmetric, if you take me and cut me down the middle, my left side should mirror my right side. It should be the same, okay? We can have what we call symmetric matrices. The first thing, in order for a matrix to be symmetrical, it must first be what we call a square matrix, which means I need to have a 2x2 or a 3x3 or a 4x4. My amount of rows and columns have to be the same for it to be symmetrical. Okay. When they're symmetrical, we have something called a main diagonal. Your main diagonal goes from the top left corner to the bottom right corner. So there's my main diagonal. If you move over to L, here is my main diagonal. It goes from the top left to the bottom right. Notice all of your elements in your main diagonal. If you look at K, K sub 1, 1 is the first number in my main diagonal, 0. Then we've got K sub 2, 2 and K sub 3, 3. They want us to list the elements in my diagonal for L. Well, my first one is going to be L sub 1, 1, which is what? 3. Drops down because it's in a diagonal. We now go to 2, 2. -5. We then go to 3, 3. And we go to 4, 4. Okay. So the numbers along your main diagonal, it should be 11, 22, 33, 44. If I expanded it to 5 rows and 5 columns, we'd have 55, 66, 77. Okay. So the numbers that go along your diagonal, your rows and columns should be the same number. So now we need to determine, are these symmetric? So the numbers that go across the diagonal, 2 and 2, do they match?
Yeah.
Good. What about 7 and 7?
Yes.
What about 5 and -5? No. So this is not symmetric.
So we always good.
Okay. Only because of that last one. Okay. We need to look at this one.
It is symmetric.
7 and 7, -1 and -1, 8, 4, 4, 8. We're good. 4 and 4, -2 and -2. So L is a yes. It is symmetric. Okay. The last thing we need to talk about is how do I add these if I have 2 of them, and how do I multiply them by a number. Okay, so there's some things we need to know about adding and subtracting matrices. One, when I go to add and subtract, my dimensions have to be the same. So I have to be able to add a 2x3 and a 2x3. Okay, they have to have the same dimensions. So let's look at A. This first matrix is a what by what? 2 by 2. My second matrix is a 2 by 2. So, yes, there is a solution. I can add them. They're the same dimensions. When I do that, my final answer is a 2 by 2. Whatever dimensions I'm adding is the dimensions of my answer. Okay. Take a look at B.
2 by 3.
2 by 3
And 3 by 7.
and a 3 by 2. Are they the same?
No.
Yeah.
You can't add those. It's not possible. You can't do it. Now we'll talk tomorrow. You can multiply those. You can't add them though. What about C?
No.
No. 2 by 3. Nikosi said that's a 2 by 3, and my second one is a 2 by 2. So they're not the same. What about this last one?
Yes.
Yes.
Yes. My answer is going to come out to be a what by what?
3 by 2.
3 by 2. Did you just say yeehaw?
Yes, sir.
Oh my. We teaching in the country now. Yeehaw.
A lot of people say I sound country. I don't sound country, do I?
Yes, you do.
Really?
Yes.
That's great.
Okay. So you're going to have a section on your test like this.
What?
Okay. So I give you the dimensions of each matrix. I tell you what I want you to do with them. You need to tell me, yes, I can do it. And then tell me what my answer would look like. So just like you did here, if I have a 3 by 2 and a 3 by 2, and I want to add them, can I do that?
Yes.
Yes, they're the same. And my answer should be a 3 by 2.
Does it make a difference if it's adding or subtracting?
Adding and subtracting is the same. Okay, so the second one, I've got a 4 by 5 and a 5 by 4. No. Six by 6 and a 6 by 6. I want to subtract. Yes? 6 by 6.
Last one, no.
And the last one is no. I can't add a 4 by 4 and a 2 by 8.
Wow, this is really simple.
Right.
No. Okay, so here's an example that you can always revert back to be able to add, subtract, or multiply by what we call scalar multiplication. Okay, so in order to add, we want them to come out to be the same size that where we started. So to add, we take A sub 1, 1, add it to B sub 1, 1 to get my answer. 10 plus 7 is 17. 15 plus 10 is 25. 13 plus 12 is 25. Okay, so each element that matches with the element in the second one get added or subtracted together. Your biggest problem is going to come into when I'm subtracting by a negative. So 2 minus a negative 1 becomes actually plus a positive, which makes it 3. So just be careful when I'm doing subtraction. Okay, that will catch you. The last thing is scalar multiplication. I can put any number I want on the outside of my matrix. And all that does is distribute in and multiply by everything in there. So my scalar is 3. So I multiply 3 by 3, 9. 3 by 1, 3. 3 by negative 2, negative 6. 3 and 5, 15. 3 and 6, 18. Okay. Questions? Okay, let's do some examples. Okay, I want to do these by hand. Then I'm going to show you how to put all this in the calculator. I think addition and subtraction are easier by hand.
Yeah.
When you get to multiplication, you're going to want the calculator. But I gave you all of the calculator rules on how to plug it in at the top. So For part A, they want me to take matrix A and subtract matrix B. So my first part of my answer is going to be -2 minus 3. -5. Six minus -4. 10. 7 minus 2. Take a minute and do the third row. Or yeah, the third row. The second row. My bad. Second row. Gucci. Got this. Not long. What's my second row look like?
32.
Okay, you said 3, 2.
Oh.
4.
Now they say it's not even all right.
You're fine. 3, 2, and 4. 8 minus 5 is 3. 9 minus 7 is 2. And like I said, the one that you're going to get caught on is that minus and negative. 3 minus a negative turns that into 3 plus a positive 1, which makes that 4. Okay? Let's go down to B. B wants me to take matrix C and multiply it by 4. Each element inside that matrix, I'm sorry, not B, C, my bad. Every element inside that matrix needs to be multiplied by 4. So we do 4 times 2. And 4 times 8.5. 34. We do 4 times 3. And 4 times -4. And 4 times 1.5. And 4 times 5. 20. Questions?
How do you do C? We can't do C.
Why can't I do?
Because it doesn't have the same.
Good. So take a look at C. C is a what by what matrix?
It's
3 by 2.
3 by 2. They want me to add that to A, which is a 2 by 3. They don't match. So all you write here is not possible. You can't do it. It's a no-no. Okay, part D. Please be careful with part D. There's 2 different things happening here. We multiply and we add. What do I do first? I need to multiply A by 2. So that makes this -4, 16 below it, 12, and 18, 14, and 6. Okay, so order of operations still come into play here. So I multiplied everything by 2. Now I need to add that to matrix B. Get me a final answer on your own before we put it up here.
Bottom.
Got it? I think so. All right, Cozy, give it to me. Oh, come on, Cozy, you got this.
I'm not good at this.
You got this.
Yes, I mean, I just.
You got this. You got this.
I told you I got
Oh, it's -1. Oh,
it.
it's
Negative.
Okay.
-1.
Think about it
Told
this
you I
way.
got it.
Think about it this way, Cozy. Here's your number line. Here's 0, -1, -2, -3, -4. So I start at -4. Then I'm going 3 in the positive direction. So that means I'm going to the right. 1, 2, 3, which puts me at -1. Does that help a little bit more with the number line? Okay. So you can always use that. So yes, -1, 8.
Put 12.
Oops. My gosh. Because I was looking at that 12 when I was. All right, -1, 8, 16,
25,
and +5. Okay. Questions? Okay. Number 2 is the same thing. That's part of your homework tonight. Skip it. You only have like 3 problems, so chill. Okay.
That's 6.
The last thing I need to show you how to do is how to find a missing number. Okay. Remember, when we're adding or subtracting, top left goes with top left, goes with top left. Top right goes with top right,
What is that?
goes with top right. What is what?
Third.
Can you give me a second to like go over this before you start asking 50 million questions? Okay. So, all we're doing is
Oh, yeah,
adding.
you're definitely missing a page.
I don't have this page. Who doesn't have this page though?
So, we
Okay, so
did,
that's the page we were just at,
Uh,
and then flip it over and whatever. Or maybe it could be in the back.
Oh. Everybody else has this page?
so now so for this part, now we have to find the number that goes into the variable.
You've got 2 copies of that page though.
It's here. Exactly. It's all the way in the back.
It's just another copy of this page.
Right, you too. Where that shit at?
Let me get through that. I'm sure I've got one somewhere. I think. We'll look. Okay.
Weeks ago.
Enough. Stop talking about it. 2, 5, and 7 go together. And -1, y, and -3 go together. So you need to set up equations separately to solve for missing ones. Okay, so I want to solve for x first. Where do I find x?
It's the 2.5 and the 10.
Okay, so x is in the top left. So watch. X, what operation am I doing? Adding. I'm adding x to 2.5, and that has to equal 10. Those are the numbers that it goes with. So what value of x do I need to get 10? 7.5. Okay, some of you will be able to just look at this and tell me 7.5. Some people need to subtract 2.5 from both sides. Y. You need to find out where y is and what numbers go with y. Well, y is all the ones I have circled in black up here. So, literally how you see it, -1 plus y equals -3. Okay. Again, some of you can look at this and say it's -2. Other people are actually going to have to solve. +1 + 1. So y is -2. Z is my last one. Z is my one circled in green. So again, we've got 3 plus -11 equals Z. Well, what's 3 plus -11? There it is. So this is literally how hard adding and subtracting is going to get.
How much harder is it
She just said, this is not hard.
gonna be? I know, I'm just saying like how much.
Multiplication is going to be all calculator, boy.
It's tight, huh?
You are not going to want to do that by hand unless it's just a column by a row. So number 4 is the same way. You need to find A, B, and C. That's the second part of your homework. Okay. So I lied. You got 4 problems. My bad. Okay. The last 2 are word problems. All you need to decide with a word problem is what am I doing?
How do you pronounce that?
Okay. What? I have no idea. These are baseball players. National League baseball players. I don't know. Okay, so the tables below show the statistics for the 2003 National League batting leaders and their statistics in the following year of 2004. Yes, these are old. Deal with it. Create a matrix that shows the change in their statistics from 2003 to 2004. If I'm trying to show change, what am I trying to do? Subtract. Okay. I want to know if I started at 591 and I went to 592, what's the difference of that? +1. So technically, I'm taking this matrix, I'm taking my 2004 matrix, and I'm subtracting my 2003 to get my final answer. So 592 minus 591, your matrix should start with a 1. Okay. I'm not going to do this with you. I think you can handle it. Okay.
We gotta go all the way through the column.
Yeah, you're going to have to do, so your final matrix should be a 3 by 6. Okay. Hold on. I got one more we got to talk about real fast. 6. 6 says the table show the distance that Jane and Jessica traveled in miles during a 2-week period on the Appalachian Trail. Write a matrix that shows the total miles driven for both weeks for both women. They want the total. So what am I doing? We need to add these 2 to get my answers.
Okay, so the other one was 7, 4, 9, 2, 3.
So don't be done.
Okay. So your homework problems are these ones. Number 2. Number 4, find A, B, and C. And then finish up 5 and 6. Okay?
Time up for that.
Yes, sir, you may.